Okay, we're going to continue our conversation about the different types of functions we've been talking about in Algebra 1, linear, exponential, and quadratic. And what we're going to look at today is how to both create or discover which one it is by looking at some data points, and then how to write the function from it. That'll be what we are learning new, different from last class. So the first step in order to do that is to determine what do we have here. First step is to determine, do we have a linear, exponential, or quadratic? So first step is to determine which model of function. Okay, so let's go ahead and do that. And we do that by looking at the patterns. You can also do it by plotting, but I don't want to do it that way. That's the shortcut way. We want to do it the way we talked about last class. So let's look at the patterns. We go from 2 to 4, 4 to 6, 6 to 8, 8 to 2. It looks like we're adding 2 each time. Let's see if we can find it. And so there's a constant rate of change for the x value. Let's see what we can do with this y value. It goes from 12 to 0, 0 to negative 4. So what's tricky here is, even though the arrow is going this way in a way, we're actually subtracting, we're looking for a common difference, so we're subtracting this from this. So it'd actually be like a 0 take away 12. So the difference for that first one would be a negative 12. And then we do a negative 4 minus 0. Well, that difference would be a negative 4. And then a 0 minus 4 would be a positive 4. 12 minus nothing would be, well, just be 12. So looking at this, we said if the first differences are constant, it's a linear function. It's a straight line. It'd be straight. But clearly, these are not the same number each time. There's not a common difference between them all. It would have to be like at the same number for that to be the case. So it's not a straight line. So our other two options now is it's either exponential, quadratic, or something completely different that we haven't studied yet, or like a trick question. So let's look at the other two. Now, for it to be exponential, it would have to have a common ratio. In other words, it would have to be multiplied or divided by the same number each time. Well, that doesn't appear to be the case here, right? Because 12 times what would be 0? Well, 12 times 0 would be 0. But if you keep multiplying each number by 0, you wouldn't have a negative 4, or 0, and a 12. So it can't be exponential. So it looks like it has to be quadratic, or it's some sort of trick question. In order to determine if it's quadratic, we would need the second differences to be constant. All we found was the first differences. We now need to find the second differences. So let's go ahead and do that. So a negative 4 minus a negative 12. And that negative next to a negative would turn it to a positive. A negative 4 plus 12 would be, oops, I have some numbers in the way here, would be 8. So the difference is 8 between these two. Let's do it this way. 4 minus a negative 4 would also be a 8. And then a 12 minus 4 would also be a 8. So what we see is that the second differences, the second time we subtracted, are constant. It's the same thing. So we know that this is a quadratic function, meaning that it's either going to smile, or if it was negative, it would frown. Okay, we did the first step. We determined which model to use. It's a quadratic. Quadratic function. But we're not finished, because now it's asking us to do something interesting. It says write that function from this data set. It wants us to write it in that standard form. How would we do that? This is where you really have to be analytical. And let's just kind of review the forms here too, because we want to turn it into standard form, and how you can do that is either with the intercept form or with the vertex form. But which one of these two are you going to use? So when I said you have to be analytical, I'm talking about you have to look at these numbers and see if there's a hint on which one of these two to use to turn it into a standard form. Well, one thing I'm going to notice this time is that there's two sets of zeros. And remember, when you have zeros, that's going to be set up more for the intercept form. So this one, I could use these points, substitute it into the intercept form, and I should be able to get the right answer. Let's give it a try. Y equals A times the quantity X minus P times the quantity X minus Q. I want you to think for a second, what would I put in place of the P and the Q right now? Right, the 4 and the 8. So it'd be Y equals 8 times the quantity of X minus 4, because if the Y is 0, the X would be a 4, X minus 8. What's the next step we would do after we do that? Okay, so yes, the next step would be to use any other point on this table here. Any other point and fill in for the X and the Y. Let's do that real quick. And this is the quick way to get it into standard form. So I'm going to choose 2 and 12. Which one of these is the Y? 12. So instead of a Y, I'll substitute it for a 12. Now, we don't know the A yet, do we? But instead of the X, I'm going to substitute a 2. This is really simple from here to solve for A. You just do the order of operations. 2 take away 4, you do the parentheses first. 2 minus 8. Everything else just gets brought down. You still do the order of operations. A negative times a negative would be a positive. Oops, actually it should be 12a, not a12. And we divide both sides by 12. And we did all that work to discover that the a actually equals 1. So once we substitute the a for a 1, since the a is a 1, I could rewrite this, but instead of an a, I would substitute a 1, which is really, I don't even need to write it at that point. So it would be y equals x minus 4 times quantity of x minus 8. So to turn into standard form, we just have to do normal order of operations. X times x would be x squared. X times a negative 8. Negative 4 times x. Negative 4 times a negative 8. Collect like terms. Whew, a lot of work, but that is how you do it. We've taken, basically what we did was we took these data sets, we determined which kind it was. It was a quadratic function. Once we determined it was quadratic, we determined which model do we want to use? Do we want to use the vertex form, the intercept form, or actually we could have used even the y equals mx plus b form. And so that is how you would do it when it's under the intercept form. Let's do one more. I told myself this video was going to be really quick. I'm just going to show you, and then as I'm working out, I can see that it's actually taking some time. So first step is, again, determine which model of function we want to use. Are we going to use the linear function, exponential, or quadratic? And how do we determine that? Well, is there a common difference for the x's? Should be. Yeah, you can see that we're increasing by 1 each time. What's happening with the y's? 8 take away 16 would be a negative 8. Right? 4 take away 8 would be a 4 take away 8 would be a negative 4. 2 take away 4 would be a negative 2. 1 take away 2 would be a negative 1. So which one do you think this would be? Would this be linear, exponential, or quadratic? Well, you can see that it's being multiplied by the same number each time are divided. It's being divided by a half, or multiplied by a divided by 2, or multiplied by a half each time. So as x increases by 1, it's being multiplied. And then remember from our rules that if it's being multiplied, it's exponential. So we know this is an exponential function. And because we know it's an exponential function, we know it's going to have an exponent in it, right? So y would equal, and we are multiplying by a half each time, so half, y equals, what would be our initial number that we started with though? Well, if x is 0, y would be 8, so it would be 8. We saw that we were multiplying by half each time, and then to a power. Okay. One last one. Let's see if I can fit it here on this page. Let's create one more, because I did one with exponential. We did one that was quadratic. Linear is probably just the easiest one to do, and I'm trying to see if I have one already made real quick. Yeah, here we go. So if we have a negative 2, negative 1, 0, 1, 2, in the bottom we'll say a negative 3, negative 1, 1, 3, and 5. And this is increasing every time by 1. We just kept it simple. And this is decreasing by a constant rate of change. This negative 1 minus 3 would be a 2. Negative 1 plus 1, or a negative 1 would be a 2. So 3 minus 1 would be a 2. 5 minus 2 would be a 2. When there's a constant rate in both, you know it's y equals mx plus b. It's linear. That's the easy part. How would you find the m and the b? Well, to find the b, if x is 0, you already know the b. B would be 1. To find the m, you can do y2 minus y1 over x2 minus x1 equals m. And it doesn't really matter which points you choose to determine the m. I don't know. I'll just choose the first 2 points. It doesn't, like I say, it doesn't really matter. So y2 would be a negative 3 minus negative 1 over negative 2 minus negative 1. You have negative 2 over negative 1 or a 2. That equals your m. So we already know the 1, so y equals 2x plus 1. Okay, this was way longer than I thought it would be, but hopefully at least illustrates the 3 different ways and how you can make your own model by looking at the data sets.